Well, hello everyone, and welcome to Prep 5. So in this prep, we're going to be looking at histograms. And histograms show a distribution of data. So, for example, it's easy to see looking at this picture. This is showing salary distribution. And what this is showing is that at less than $25,000, we've got, it looks like, one person, $25,000 to $30,000. Looks like two, $30,000 to $35,000, three, $35,000 to $40,000. Looks like about six, $40,000 to $45,000, 23, and so forth. Right? So we're simply showing distribution of salary data, and here's the raw data over here. So we're going to be doing this multiple ways. And we're also going to be capturing statistics about this distribution, right? Because these distributions roughly follow a bell-shaped curve, which means that we can use the mean and standard deviation to describe the distribution. And in fact, in this first one, when we say 50-10, what we mean is that we think that the mean is going to be about 50,000 and the standard deviation is going to be about 10,000. So the organization aims for an average salary of 50,000 with a standard deviation of 10,000. If salaries are normally distributed, right, that's the bell-shaped curve, then we would expect 68% of their employees to earn within one standard deviation of the mean and 95% of their employees to earn within two standard deviations of the mean. So why would we expect that? Because that is a property of a normal distribution, that the majority of values, 68%, are within one standard deviation either side of the mean. So that would mean if you add 10,000, that would mean 60,000 on the right-hand side, and then on the left-hand side, subtract 10,000, 40. So 40,000 to 60,000 should be 68% of the salaries. And then 95% of the salaries should be two standard deviations, which would mean from 30,000, right? Subtract 10 twice, and then add 10 twice, so you get 30,000 to 70,000. Should be 95% of the employees. And that's just a property. It's called the empirical rule. It's just a property of normal distributions. So here's a sample of 100 employees, because we want to make it easy to show these percentages of round numbers. And you're going to complete the formulas, graph the result, and answer the questions. Okay, so let's go ahead and start with the formulas. So what's the minimum value here? So we say equals min, and then we highlight all the salaries. Okay, so the lowest salary is $18,000. Now let's see what the biggest salary is. Equals max, and then same list of salaries, and we see here that the highest salary is $75,969. Okay. Now let's go to the middle, right? So if that's high and low, what's in the middle? So the mean is called the average in Excel. So in the middle is 49,802. There's another measure of central tendency called the median. The difference between the mean and the median is that with the median, it would be like you put them all in a row, and then you find the one that's at the balance point, like literally dead center. So let's see if those two are close. And they're very close. So when you've got the mean and median very close to each other, then the statistic that you always report is the mean. Why? Because the mean can be used for lots of statistical tests that are associated with a normal distribution. Okay, well, now that we got those numbers, now we can drop down here and get the range, because the range is going to be the max minus the min. So equals this maximum value minus this minimum value. There's your range. And we can also get the standard deviation. So that, this is a sample of employees. It says sample. So we're going to type STDEV.S. That's standard deviation of a sample. That's what the .S is. It's a standard deviation of sample. And we see that that is 10,240. That number is not formatted like the other ones are. So let's get that formatted. Let's go ahead and do some grading here too, just to see how we're doing. So, looks pretty good so far. Okay. Now what we're going to do is we're going to see, okay, well, what would it mean? What is one standard deviation less than this mean? So what we do is we take this mean and simply subtract from it the standard deviation. So that's what one standard deviation less than the mean would be. And on this side, we take the same mean and we add the one standard deviation, which is that value. Grade both of those. And so we see that that's 39,500 to about 60,000 is one standard deviation either side of the mean. And what we're claiming up here is that we expect 68% of the salaries to fall in that range. Now let's look at two standard deviations less. So that's going to be that same mean minus 2 times the standard deviation. And we'll format that. And then we'll go that same mean plus 2 times the standard deviation. Format that as well. And we'll grade again. Okay, apparently that's too low. So let's see what I did wrong. Oh, okay, I missed this value. Let's move that up. And grade again. There we go. All right. Well, let's keep going. So now we're after, well, what are the number, how many of these values, these salaries, really did fall in the plus or minus 1 standard deviation, in other words, from 39,000 to 60,000. So we can actually count that using the count function. So we say equals count ifs. The criteria range is this criteria here. It's a range, so we lock it. And then the criteria is that it's that we need to be greater than that one because that's the lower bound. All right, so now we'd like to just put greater than here, but we can't. We have to put it in quotes. It's just a strange thing about Excel. So we say it's greater than or equal to, and then we put an ampersand to basically say what it's going to be greater than or equal to. So we want to be greater than or equal to that lower bound. In other words, the 1 standard deviation to the left of the mean. All right, so that was the first one. But we also want to be less than 1 standard deviation on the other side. So we do the same thing again, grab the same range. It's a range, so we lock it. And the criteria, again, has to be in those funky quotes with the ampersand. And then we click on the upper value of the range, which is the plus 1 standard deviation. That should be everything. Close the quote, hit enter, grade it, and it looks like we're really spot on. 68 of the 100 employees were between -1 and +1, which is exactly what we expected because of the empirical rule. Now let's see how many employees are between 2 standard deviations either side of the mean. So it's going to be effectively the same thing. Equals countifs. Same range of numbers. Lock it. And then we want to be bigger than that range, so funky quotes, greater than or equal to, and then the ampersand. There's the lower bound, and then same range again. Lock it. Funky quotes, less than or equal to, ampersand, and then the upper bound, the 2 standard deviation upper bound. There, so from 2 standard deviations under to 2 standard deviations over. Grade that. All right, so we get 96, and we were expecting 95%, so we got 96 out of 100, or 96%, so that's really close. So the empirical rule held. All right, I'm going to come to this underflow and overflow in a second. We'll get there. Relax. All right, so the first question is there support for this target? Because that was their target, what they aimed for. And the answer is yes. What kind of graph is this? Well, let's build the graph and then we'll decide. All right, this graph is called a histogram. And the way that you build a histogram in Excel, it's a wonderful feature of Excel. What you do is you simply highlight your data range, go to Insert, and under Recommended Charts, you'll see histogram is one of the recommended charts. And then we'll drag it up so it's near our chart, so we can kind of size it to match the model. Okay, and you'll notice that it looks different, right? The model's got more bars and so forth, but we can actually change all that. But in order to change all that, we actually have to look at the model, and in particular look at, this is called the underflow value, the 25,000. It's going to be a catch-all at the lower end. And here's the overflow value, which is 70,000, so that's a catch-all at the upper end. So now we can come back here and put those in. So it's 25,000, 70,000. Grade that again. Cool. What's wrong with that? Oh, formatting. So format and format. Good. Okay. So 25,000, 70,000. So now we come into our chart. What we do is to get to the menu where we can configure that, we simply click on this data range here. And you got to be careful. If you click like twice as slowly, it just selects a bar. It's not what we want. So we need to click twice quickly. That brings up this menu over here, the Format Data Series. Another way to get that menu to come up if you're having trouble is right-click, Format Data Series. That'll bring up the same thing. Okay, so now we fill in the overflow and underflow. So remember the overflow was 70,000 and the underflow was 25,000. All right, so that's good. It's looking a little closer, but we still don't have enough bins. So we're going to change this to number of bins, and then we could count these. So it's 1, 2, 3, 4, 7, 8, 9, 10, 11. So this should be 11. And now it matches. And then the last thing we have to do is the chart title. 50-10 salary distribution. Now, you're probably wondering, why 11 bins? How did that happen? It's actually kind of pretty straightforward math. You look at the 25,000 here and the 70,000 here, and the difference between those two numbers is 45,000, right? If I want these in between to go 5,000 at a time, then I take 45,000 divided by 5. I need 9 bars effectively in the middle, but then I still have a bar at the end and a bar at this end. So 9 plus 2 is 11. That's how I designed it, so I'd get bins that were a nice width each. Kind of a roundabout way of doing it, but it works. Okay, so the graph type is a histogram. Number of data series is just 1 because it's just salaries. Graph title is 50, 10, salary distribution. Don't worry about it, overflowing the box. X label are none, so it's none and none. And we're all done with this one. Okay. Now, why make all this? I mean, who cares? You should care, because if you're going to go work for an organization, let's say that they tell you, well, our average salary is 50,000. You kind of want to know, not just the average, you want to know this spread, right? How are salaries spread? In other words, what does this distribution look like? Because that's going to tell you whether or not you have room to grow in terms of salary at the organization. So it looks here like you could go up in salary, to about here, but then you need to know, well, how long will it take me to get there? But at least it's possible. You could also start a lot lower, right? I mean, it's all going to depend on where you fall out. So now let's look at, and the reason I mention that is because what if you went to work for an organization that had a smaller spread in salaries? In other words, everyone's clumped in tighter to the middle. And that would be a 52 histogram because the standard deviation would be less, so everything comes in more. And you can see that here in the salaries, right? Everyone's earning between 46,000 and 51,000. So no real low salaries, but no real high salaries either. Where would you want to work? Here, maybe when you're starting out, maybe this organization is great because you're going to definitely not get lowballed, but maybe not a lot of room for growth in your salary. But let's run the numbers. So same kind of problem, except we're doing 52 rather than 50-10. So the minimum salary the maximum salary, the average or mean, kind of use those terms interchangeably. The median. And we would expect, since it looks bell-shaped, the mean and the median to be really close. And they are. That's great sum. Okay, the range. Max minus the min. Standard deviation. And keep grading. Okay, so what's one standard deviation less than the average? It would be equal to the average minus, there's your standard deviation, which is around 2,000. I mean, it's close, right? And equals that plus the standard deviation. Great again. Okay, and then two standard deviations would be equal to that minus 2 times the standard deviation format. That equals the average plus 2 times standard deviation format. Great, everything. Okay. So you can see the salaries are really packed in. 95% of our employees should end up between about 46,000 and 54,000. So let's see if it's true, right? If the empirical rule holds out. So we'll do the count ifs. Lock the range. And this is the greater than or equal to ampersand. The lower bound of one standard deviation, and then same range. Is less than or equal to the upper value. So it's really close, right? Instead of 68%, we have 64%, but really close. All right, now let's look at two standard deviations. Equals count ifs. Greater than or equal to the lower bound, 2 standard, which is this one, and then same range. Less than or equal to this upper bound of 2 standard deviations. And so that's 96, which is right around 95. So the empirical rule seems to hold with our data set. Okay, so is there support for the target? Absolutely. Now, let's finish filling this out with the underflow and the overflow. So for that, we actually have to look at it. So this looks like 46,000 as the underflow and 53,000 as the overflow. Looks like it's a formatting thing. Okay. And if you're wondering, well, how do you pick underflow and overflow values? You basically pick a value that's around 2 standard deviations less and 2 standard deviations more. Why do you do that? Well, because that's going to be 95% of your values are going to be, within that range. So you're only taking care of the last 5%, which you're effectively splitting 2.5% here and kind of 2.5% there. So that's how you sort of figure out what your underflow and overflow should be. But obviously try to pick whole numbers so that your bin sizes are easy to read. All right, so the graph type again is a histogram. Oh, well, actually we should make the graph first. but it will be histogram. So let's make this graph. So highlight the data series, insert, and the recommended chart. There it is, histogram. Okay, double click this or right click, format data series, both do the same thing. Come over here to the bars and we'll put in our underflow and overflow, which is supposed to be 46 and 53,000. And then we'll adjust the number of bins. How many? 1, 2, 3, 4, 5, 6, 7, 10, 11, 12. It looks like I matched it. Okay. And then change the chart title. It's 52 salary distribution. Now we can answer our questions. Number of data series, just one. Graph title, 52. Salary distribution. So we're none. None. Okay. Sorry about that. These videos are a little bit more lengthy because there's a lot going on. All right, so that's how you do it using the built-in histogram that's part of Excel. And now we're going to look at sort of an odd case, a little bit of an odd case. So if these were normally distributed, this one says that it's skewed. Well, what does that mean? It says it's skewed to the right. And what that means, the reason it's called skewed right is because it tails off to the right. You always identify the skew with the direction that the tail points. The tail is pointing to the right, so it's skewed right. So this would be skewed right salary distribution, which I guess as an employee, that's a good thing, right? There's nobody over here getting lowballed on salary. So let's look at the statistics surrounding this one. What happens to the statistics? How do they change when it's a skewed distribution? So it equals the min so minimum salary is 40,000. That's kind of nice. Nobody's getting 25,000. And the max okay, the mean so the mean's about the same. We're still at around 50,000. All right, the range is equal to the max minus the min, and the standard deviation, STDEV dot S. Right. Standard deviation is not looking quite at 10,000, right? It's a little bit lower. The standard deviation has kind of gotten messed up a little bit because of the skewed distribution, at least messed up relative to where we kind of want it to be. All right, let's look at the median, because that's the other measure of central tendency. And you can see it's close, but about 2,000 less. Now, when you have a skewed distribution, the number that you're really supposed to report for central tendency is the median, not the mean. Because the median gives, and especially then the more skewed the distribution is, the more you want to report the median. In this case, we could probably get away with reporting the mean, because they're kind of close. But if these were dramatically different, you would always report the median. Okay, so now let's see what one standard deviation less looks like. So equals the mean minus standard deviation equals the mean plus standard deviation. And then look at 2 equals the mean minus 2 times the standard deviation equals the mean plus 2 times standard deviation. Okay. Now let's see if it actually holds. Let's see how many salaries are in this range. So equals countifs and the criteria is going to be the funky greater than or equal to, and then the ampersand, the lower bound, and then the same range. Less than or equal to the upper bound, one standard deviation. So this basically tells how many people earn between 42,990 and 57 and change. 67. Well, that's really close to 68. So even though this distribution is skewed, because it's not horribly skewed, it's actually obeying the characteristics, so far at least, of a normal distribution. And that's good news, because statistics are much easier to compute on a normal distribution. So, as we'll see later in the course. Okay, so then let's look at the 2 times. Oh, sorry. Equals countifs. Do the funky thing, greater than or equal to this lower bound, and then same range, less than or equal to the 2 standard deviation upper bound, 95. Again, that's really close to the flesh of dead on, what we would expect. So it's actually the properties work. Now let's look here. We have 43,000 at the lower bound and 68,000 at the upper bound. Lower bound, 68, 1, 2, 3. Upper bound. Right. Now, what's interesting about this is that the underflow is actually greater than the 2 standard. I mean, like, it's significantly different. Remember I said we usually try to go around the 2 standard deviation for the underflow and the overflow. On the overflow side, makes a little more sense. On the underflow side, it's kind of far away. And that's because the distribution is skewed. So you kind of have to look at things to look at what makes sense and make adjustments as need be. All right, support for the target. Yes. All right, and the graph type is a histogram. Oh, let's bake the graph. Make it bigger. Oh, maybe not that big. Okay. Double click here. Let's see how many. Okay, that means you have to do the overflow and the underflow. So we're going from 43 to 68. So 68,000 is the overflow. 43,000 underflow. And then let's count bins. 1, 2, 3, 4, 5, 6, 7, 8, 9. This one counts 10, 11, 12, even though there's nothing in it. Okay. And it looks like we got it. Looks like we matched the model, and then let's just put in the chart title. Skew, right, salary, distribution. Graph type again is a histogram. Number data series 1, graph title, skew, right, salary, distribution, none. Sorry, I'm running into trouble on the graph title. Kind of think this was supposed to be 50-10 skew right. Salary distribution. Let me see if that. Aha. Okay, so what's on the model is wrong. And what we should have here is the 50-10. So, my bad. 50-10 skew right salary distribution, and that's what you should have here too. Okay, so what we've seen here are 3 histograms. We're using this wonderful feature in Excel to be able to create a histogram directly off the raw data. It's literally mind-blowing, incredible that it can do that. But we also wanted to understand the data. And so the way we were developing an understanding of the data was kind of creating almost like a number line up here. We picked the midpoint, the min, the max, and then points in between, we use the standard deviation, right? Has 1 standard deviation less, 2 less, 1 more, 2 more. And then we picked our overflow and underflow to go into the histogram. And then we counted. We said, does this empirical rule, which predicts that if you have a normal distribution, this is what should happen, does the empirical rule actually hold? And it does hold, whether we have sort of almost a perfectly bell-shaped curve, or even if we have slightly skewed distribution. So that's kind of cool to see statistics in action. All right, now on the next video, we're going to effectively do exactly the same thing, but this time what we're going to be after is, well, what if your boss kind of wants to see these numbers? In other words, they want to see a table that says, well, how many people fall into each of these bins? I mean, graphs are nice, but maybe they actually want to see a table of values. The histogram won't give us the table of values. So there's 2 other ways that we can get the table of values. One is using pivot tables, and one is using formulas, and we're going to see both. in our next video.